When you get offered the last slot at a conference, it's a sort of double-edged sword. You're never quite sure how many people are going to be there, so you're always kind of reticent about saying yes too quickly in case somebody else takes that, and then you might get a different slot and therefore stand a better chance of getting more people in your session. But I'm pleased to say that you guys look keen. And you're all here at 4:30 p.m., so thanks for sticking around for the last session. My name's Ian Massingham. I'm in the evangelism team at Amazon Web Services. And coming to events like this that aren't actually AWS events, it's actually really helpful for me to understand where people are in terms of their knowledge of AWS in the cloud. So who here is using Amazon Web Services today as part of their application infrastructure? Okay, a minority, but a substantial minority of people. So let me just say a couple of things about AWS first of all, and then we'll talk a little bit about some of the challenges that it solves and get on to the meat of this discussion, which is how organizations are using the cloud to solve data problems at scale. Okay, so AWS is a platform, a cloud computing platform that you can use to build and operate applications and information services. We started back in 2006. And when we started, we had very rudimentary building blocks. We had compute resources, we had storage resources, and that was about it, okay? And we were experimenting there. What we found actually was developers really liked some of the fundamental characteristics that these resources came with. So they were on demand, elastic, you could use what you wanted and pay for what you used, then you could return the resources and stop paying for them. And they had fundamental characteristics of security, scalability, and defined reliability as well. And developers really liked this. They really liked using these services that we provided. And from there, we've iterated. Now we have over 70 different services. And those services can play a role actually in very many different application types. Okay, so you can use them as building blocks upon which you build applications and services to get the outcomes that you want. We'll return to that in a little bit. Another question for you. Who here has spent some time in their career writing software or architecting software? That's a much better answer, so most of you, okay. And who got into that because they thought that it was fun to do? Who got into writing software because they enjoyed it? Something that always amazes me that the majority of people always answer yes to that question, okay? Because when I think about my own life, if you played it backwards, it would be about somebody that got happier and happier as they learned less about computers. You sort of run it backwards. But when you start with development, it's great fun, right? It's an interesting intellectual challenge that you can put your brain to work at, pretty hard actually, to solve logic, mathematics, and holding the sort of broader architectural picture of whatever it is you're building within your mind is something also that I find really enjoyable. The problem is there's a lot of stuff about other aspects of running applications that just isn't fun, okay? Stuff that definitely is not fun. So you've got to deploy applications. Now this has got a lot better recently because there's a lot more tooling that's arisen, being developed and created to make application deployment a lot more repeatable and a lot less risk-free. But I'm sure we can all remember nights spent, maybe Friday afternoons and Saturday mornings spent wishing I hadn't done that deploy on a Friday. You know, so it's not necessarily fun. Operations. Operations, of course, is fun for developers. But it's not that much fun for people that work in ops, right? I spent a lot of my career in operations, and there are things about operations that are hard to do. You've got to scale applications, you've got to make sure that they're secure and that they meet the compliance and security obligations that you might have placed upon you by stakeholders, maybe by external regulatory bodies. Hard to do. You want to make sure that you're operating things in a way which is cost optimal in light of scaling security and operational challenges that you might have. You've got to manage the life cycle of applications. So they're not fixed at a particular point in time. Well, they certainly shouldn't be. They need to be modernized. They need to be kept up to date. They need to be maintained. Also difficult to do, okay? So why the cloud? Well, the cloud can help solve a lot of those issues by turning the undifferentiated heavy lifting associated with operating this platform into a collection of services that you can consume. So rather than having to engineer and operate all of these underlying components yourself, you just consume them, okay, as a set of service options that are available to you. Obviously, one implementation here is AWS. Now, let's talk briefly about what makes AWS different from some other providers. The first thing is adoption scale. So, this is another question, okay? You're starting a brand new business tomorrow, you've got your own money or your investors' money in your pocket. And you need to use that money in order to get to an outcome, which is a viable business model for your new startup, right? Who's going to spend their own money or their investors' money on data center infrastructure, on machines, and on software? Yeah, I'm looking hard, but I don't see any hands. So if you're building a startup, it's just the way that you do it. You build startups in the cloud. And the reason for that, I've already described. Capital-free model, immediate access to technology, very scalable. The platform has fundamental characteristics that you can build on top of. So it's a really good place to create new businesses and to create new business models. It's actually a really good place to scale them as well. If you want to build the next Airbnb or the next Spotify or the next Pinterest or the next SoundCloud, it's a pretty good chance you'll do that on AWS, because if you do become successful, you won't become a victim of that success. You can scale to great heights on this platform, and as you scale, your cost per user will actually fall away as a result of your scale. So it's an excellent platform for building new businesses. And you'll know that many of these businesses, they do a lot with data. Data is really core to the success of their models. One very good example of this actually would be Airbnb, just to return to them for a second. So they run almost entirely on Amazon Web Services. They have almost no infrastructure anywhere else. And they're actually one of the world's largest provider of accommodation services. If you consider them in comparison to something like Crowne Plaza Hotels, well, Crowne Plaza Hotels have about 105,000 hotel rooms around the world. So that's their inventory, okay? If they sell everything, they've got 105,000 occupied rooms. Airbnb have about 500,000 guests staying in their brokered properties every single night of the year. So they're about 5 times bigger than Crowne Plaza. They emerged and had almost no customers in 2012. So in that 4-year period, they've built a business which is massive in scale. It's also very distinctive in its characteristics. They don't own a single property. They never have a receptionist that welcomes somebody to their properties. They never launder a single towel or bedsheet, and they actually never check anyone in or out. That's all done by their hosts. So they have an intermediary-based model where they connect supply and demand. It's really quite elegant when you think about it. They also use data. So they have about 2,000 machines within AWS that run things like their website, their APIs, the back end for their mobile applications. Periodically, they apply an analytics cluster, which is about twice as big as that, about another 4,000 machines. They're used to work and operate on data that's gathered as customers use their products. Okay, so use that large analytical cluster to gain insights into how they might improve the experience for their customers and achieve their business outcomes by doing that. And in fact, there's a very interesting blog post on the Airbnb engineering blog, which is called nerds.airbnb.com, where they talk about how they managed to increase their conversion rate through analyzing the clickstream, the path that customers took through different versions of their web and mobile apps that were active concurrently. So they use data to determine the outcome of A/B testing cycles that they run. By doing that, they were able to convert 4% more of their visitors into paying guests using that analytical pipeline that they built, all built on AWS. So that's startups. We all know about startups. Probably those of you that are working in organizations that have been around a while are thinking it's terribly simple for startups because they don't have legacy. You know, they don't have anything that they need to change because they don't have anything when they start, and they also don't have culture. Well, they do have culture, but they have the opportunity to build culture that reflects the current state. They don't have legacy culture. I used to work in telecoms. I can tell you legacy culture is a killer. It's hard to deal with, okay? So they don't have that. On the other side of it, we have a lot of customers that do have that are in that category of organizations that have been around a long time. We can pick a few examples from this slide of organizations that are using data in an interesting way. One good example would be Novartis. So high-performance computing applied to simulation data for pharmaceuticals. What they do is look at models for organic compounds, try to determine which organic compounds might be a good fit for certain medical use cases, particularly in things like inhibiting some of the proteins that are involved and cause cancer. Okay, so they've done various high-performance supercomputing runs to try and solve this problem, working with a software provider called Schrödinger, which does materials analysis, and they do this in the cloud. Actually, Novartis were able to complete 243 years of CPU time in 9 hours by using a massively parallel supercomputing cluster that was built in the cloud with 38,000 CPU cores. And they put that to work for that cancer drug use case. That's a very good compute-intensive use case. If you're looking at data, how about Philips up here? They connect medical imaging devices to the cloud. So when you have a CAT scan or an X-ray, instead of having that information, the data that that device generates, locked inside the hospital, they stream that information directly to AWS from the medical imaging device. And then they have a set of mobile apps that clinicians can use to view X-rays, CAT scans, and MRIs wherever they are in the world. It's all done within a compliance framework called HIPAA. It really improves the care for patients because the diagnosis is that much more immediate. And it also changes the business model for Philips because they're no longer having a once every 3 or 5 year conversation with customers to sell them a CAT scanner. Instead, they've got a regular subscription business model where customers pay for the amount of data that they accumulate. And they can run other models over that accumulated data to enrich visualizations, and in some cases, even head towards diagnostic through mathematical models. Another very interesting use case for large-scale data storage in the cloud. They have about 16 petabytes of medical imaging data that they store within AWS today. So that's a little bit about usage. I actually spend more time on this slide talking about more of these use cases, but we're a little bit limited for time. If you want to know more, just go here. All of these are written up, or they have videos which describe in more detail how these customers are using the cloud to achieve particular outcomes that they're aiming towards. So that's a little bit about who uses us. The other thing that's changed a lot since 2006 is service breadth. So back in 2006, we started with a couple of things: an object store called Amazon S3 and a compute service called EC2, which is virtual machines in the cloud. Very rudimentary. They're still here. They're down here on this chart at the bottom in what we call core services. And you can consider these core services primitive building blocks, pieces of Lego that you can snap together, install software on, and still use to get outcomes from the cloud. So managing the software deployment and managing the infrastructure yourself and constructing the architecture out of low-level building blocks. Over this 10-year period since we launched, what we've really focused on is trying to add further abstractions. So instead of having to work with those low-level building blocks, instead you work with abstract service constructs. Okay, now one of those might be something like a data warehouse, a Hadoop cluster, a real-time data stream processing and analytics service, or an open source tool like Elasticsearch, which is wrapped inside a managed service. Those are just a few of the analytics and data management services that we provide. The point about these abstractions is you don't request machines and then have to build them. You request a service which is intended for a specific outcome or for a specific use case. So I would say I want a Redshift data warehouse, I want 32 nodes, I want solid state disks, and a few minutes later you'll have 32 nodes assembled in a cluster with the appropriate interconnects, the appropriate software, and provisioned into your AWS account for you to start loading data onto. And you can contrast that with the process you might go through if you were going to build that yourself. Often ask customers how long it would take them to specify, select, procure, implement, and test a data warehouse in their own infrastructure. And the most common answer that I get back for that is 6 to 9 months. Okay, so you can do that in about 10 to 15 minutes with Amazon Redshift. So why wouldn't you do that? Why would you default to this long cycle time? You might as well experiment with the cloud. If you find that you can get the outcome that you want, that's great. Use that service. If you can't, you can still default back to what you previously considered plan A, and it's only going to add maybe a week elapsed time to your project. So it's a very efficient way to get access to the resources that you need to build particular application types. Okay, so that's a little bit on services. We have some other interesting stuff here, by the way. All this red stuff here is all security and compliance services. It's one of our largest investment areas to add services that allow customers to protect, audit access to, apply policies to their data and their infrastructure, and make sure that they're meeting the security and compliance obligations that they have. So that's a very important area for us. And over here, we've got a complete platform of services for IoT, so for data ingest, managing connected device fleets, dealing with virtual representations of connected devices in the cloud so that you can work with them asynchronously while they might not be connected to the network, and a variety of other things as well. And this is an area that we're focusing on, really, trying to simplify the process for application developers of various types by building more service abstractions that allow you to focus on the outcomes that you want to get rather than on this heavy lifting of operating platform components that are just really kind of unnecessary plumbing in many ways. Okay, so let's move on and talk about the main part of the talk, which is using the cloud for big data apps. And you might have guessed from my discussion earlier about primitive building blocks and abstracted services that there are actually two ways that you can tackle this, okay? The left-hand side of this slide is all about open source projects and commercial tools that are available to help customers tackle large-scale data challenges. And you can run all of those tools on Amazon Web Services. You can use the primitive building blocks of EC2 instances, networking with services like VPC, storage of various types, and you can install your own software and operate your own software on the platform. And if you do want to do that, we have EC2 instances, these virtual machines, that are targeted for specific workload types. We have an EC2 instance family called the i2. Each machine contains a large array of solid-state drives with very good I/O performance, very low I/O costs. So you could build a cluster for Cassandra or MongoDB using those sort of instances. It would be a very cost-effective way for you to access high-performance solid-state storage for your non-relational database. Let's say you want to run a large in-memory database in the cloud. We've got another instance family called the X1. Each machine has up to 2 terabytes of RAM in it. So you want to run a large in-memory database. We've got a specific machine type, an EC2 instance type that's targeted specifically on that workload type. That also comes with 20 gigabit bisection networking, by the way, so it's very high-performance networking interface as well. Or maybe you've got large volumes of data that you want to stream from your EC2 instance. You're not concerned with random I/O performance, but you're concerned with streaming throughput. Maybe you want to run EMR or Hadoop natively on an EC2 instance cluster. We have another instance family called the D2. Each machine comes with a large amount of rotational disk with very good streaming performance. So you can optimize these low-level components around particular use cases and choose an instance type, infrastructure type, which offers you the best price for performance for the particular type of resource that your application consumes the most of. Okay, so that's on the left side, building our own platform, your own platform, using these primitive building blocks of machines and networks and storage infrastructure. And that's fine, you can do that. My hypothesis maybe is it's not the quickest way to get to the outcome that you want, but it offers you complete flexibility and control to build whatever you want. Now, if you want to avoid that and get to results more quickly, then there's another category of services on the right-hand side of the slide, which are some of the tools that we have which are relevant to this particular class of applications, this particular type of use case. EMR, it's Elastic MapReduce. It's a framework for running managed Hadoop and Spark clusters in the AWS cloud. A little bit like Redshift, you just dimension the cluster that you want to run, specify what Hadoop ecosystem tools you want to install in that cluster, and a few minutes later, you'll have an environment available for you to use to run your Hadoop or Spark jobs on. You can actually fully automate that with actions, startup actions called bootstrapping actions, and also in passing automated execution start points to your cluster at creation time. And customers will build these clusters and execute jobs on them on an on-demand basis. So rather than having Hadoop sitting around the whole time, you just start it every 4 a.m. when you need to process your large data set. You can do that in a fully automated, hands-off fashion and have your results deposited ready for when you get in the office at 7 a.m. the following morning. See, many customers move towards complete automation there. And one of the reasons that you can do that we'll come to in a second. And then we have a variety of other tools. DynamoDB, it's a fast non-relational database with consistent and sub-10 millisecond performance that you can use for hot or frequently accessed data. It's excellent for lookup tables. You can combine it with EMR or our Redshift service. You can also use it as a native backend for mobile or high-performance applications where you might have very hot data, but you don't require a relational data model. So that's another service that we have. And we have a lot of other services on there. I'm not going to spend the whole session talking through these, just to say that we have a complete toolkit of services that developers that are developing data-centric applications can use to create apps on AWS. So what about design patterns? Okay, and you can consider these design patterns generic, either using AWS services or using primitives, using those building blocks and building your own open source tools on top of it. Now, the first thing I talked about there was this idea of turning your analysis resources from resources that you run permanently to resources that you run on demand. So not having your compute resources sitting around idle, only bringing your compute resources to bear when you've got an analytical task that you want to use them for. And one of the patterns that we see very, very extensively is the idea that you should decouple storage and processing, building either two-stage or multi-stage pipelines where data is stored and then you apply compute resources to it periodically when you want to process the data. So this would be Amazon S3 in our model. This might be Elastic MapReduce. This might be Redshift. It could be other tools that you develop and operate yourself. Why is this a good pattern? Well, it's a good pattern because Amazon S3, our storage service, it's highly durable, it's regionally based, it offers very good encryption features, and it's very low cost, and it's connected to our compute resources at very high bandwidth. So you can stage your data inside S3, periodically create an EMR cluster or a Redshift cluster, and then rapidly load data from S3 into those computing resources for analysis. In fact, in the case of EMR, we provide a software driver that makes our S3 service look like HDFS. So you can work with it just like the Hadoop distributed file system. It'll be transparent for your Hadoop or Spark applications, but the data benefits from high durability, and it persists after your Hadoop or Spark cluster is terminated. So you can decouple storage and processing activities, and through this pattern, you can build much more cost-effective analytical applications. They're also much more energy efficient, by the way, so they also reduce the amount of carbon that you're going to be producing. So you don't run your Hadoop clusters other than when you want to use them for processing. So that's a lot of benefits. Multiple processing applications. This is quite an interesting pattern. So we've got another service here which has appeared for the first time called Amazon Kinesis. And Kinesis is a service for reliably and durably maintaining ordered streams of records. You can ingest data at any rate, so creating additional shards adds additional throughput in terms of bandwidth, still maintaining the appropriate sequencing across different shards. And then once you've got your records in the stream, you can use them for a variety of different purposes. You can feed those records to a persistent store like Redshift or Amazon S3 using a service called Kinesis Firehose. That's our Amazon Kinesis S3 connector that you can see at the top there. And we can also operate on records in real time using an event-based computing service called AWS Lambda. So each time I get a record or a batch of records, I can initiate and execute arbitrary JavaScript, Python, or Java code. And I can use that for things like real-time dashboard updates, updating machine learning models, inserting summaries of those records into a non-relational database that might drive a real-time component of my app. So I can mix and match different services operating on the same data stream if I use one of these stream processing services. Of course, I can build other open source stream processing services as well as Amazon Kinesis, but in that case, I have to take care of things like durability, failure, and scalability management, okay, as part of my responsibility. If I use Kinesis, those characteristics will be delivered as a component of the service offering. What about operating with multiple consumers on the same data stream for analytical purposes? Here we've got several different operators. So Kinesis itself has a built-in analytics service called Kinesis Analytics. Here I can operate on data in a stream using an SQL-style language to extract records, summarize records, and forward records based on their content. So a simple example might be alarming. Maybe I've got a stream of temperature data coming through that Kinesis stream. Whenever I hit 75 degrees, I want to trigger an alarm somewhere. I can put an arbitrary SQL statement in Kinesis Analytics saying if any record has a temperature value greater than 75 degrees, forward it to this endpoint. Okay, so I can receive real-time alerts about the contents of a data stream without having to run any compute. Could also use something like Apache Storm to get the same output. I can use other analytical tools with these other data stores that I've created. Here I've got DynamoDB and S3, so I've got some lookup data in DynamoDB, which is very high performance. I've got my deep archive of data in Amazon S3. I've got EMR sitting on top of that with Hive, and I can aggregate data across those two different sources using an SQL-style query language. Maybe doing lookups in Dynamo, while the bulk of my cold data is stored in S3. And then over here, I can feed the same data from S3, again using EMR, into a Spark model, maybe for machine learning or for some other analytical output. And you can see what we're developing here is a model where we look at different persistent stores and different architectural approaches based on a couple of different vectors. how hot is the data, so how new is it and how frequently accessed is it, and then what kind of processing latency do we need? Are we happy to wait a long time for the results of our queries because they're essentially non-real-time batch queries, or do we need our responses back very quickly in order to allow us to take real-time decisions and act very, very quickly on the contents of data that we might be accumulating or receiving? So you're going to mix and match different services to get different outcomes. So, just to quickly summarize what I talked about there, this decoupled data bus, it's a mechanism for allowing you to decouple compute and storage, and by doing that you can reduce costs, actually reduce the amount of compute that you need to run, which is also good for the environment, as well as allowing you to apply some of those different techniques to data depending on its characteristics. Can use the right tool for the job, optimizing across those different axes that I showed you a second ago. And obviously these slides will be available, so take a look at that. It's quite a busy slide, but there's some good insight there into which tools you can use to deal with data at different stages of its life cycle. Now there's another Lambda here. So this is not AWS Lambda. This is an architectural pattern called the Lambda architecture. This is for two-speed data, where you want to have long-term insights that you generate from a deep archive of data that you accumulate over time, but you want to combine those with real-time visibility of emerging patterns in data or alert-style events. So you can combine those two things together if you take advantage of one of these data stream management components within your architecture. We think it's a good idea to use managed services, build your unique application components, but defocus on things that have been done before. So try to avoid some of the heavy lifting associated with running this kind of infrastructure. And if you adopt these techniques, you can achieve some good outcomes, actually processing and getting insight from large amounts of data while still being very cost conscious. Okay, so that was a quick summary. If you want to learn more about any of the stuff that I've talked about, go here. So we have a resource center on the AWS website here, which collects together a lot of different resources for running analytical workloads in the cloud, both real-time data warehousing and other service patterns like machine learning, for example. So you can find more if you check out this URL here. And I would encourage you to go and build in the cloud and have fun tackling some new challenges using these new architectures. Okay, got 2 minutes, so I'll take a couple of questions if anybody has a question or two. You're going to get a mic in a second, I think, over here on the... Mm-hmm.
Thank you. Thank you for the talk. Could you please reveal some plans on making some sort of environment for deep learning? I know that there is some GPUs on EC,
yep.
But I think that, for example, NVIDIA came up with NVIDIA Lab, which is more kind of comprehensive for data scientists to use.
Yep, yeah. So it's an area that we obviously get a lot of questions from customers about, which is normally a good indicator that there'll be teams in AWS working on it, but I don't know what's on the roadmap for that particular area. What I can say is we recently shipped a new family of instances called the P2. The P2 family of instances includes NVIDIA K80s, which I think are similar to the FPUs, the floating point units that are used for the service from NVIDIA that you talked about. And the big instances have a lot of power. They have 40,000 floating point cores. I think it's 760 gigs of RAM and also 32 Intel cores in them, so they're very powerful. We also, at the same time that we announced those instances, announced the new Amazon Machine Image. Now, are you familiar with this, armies? So Amazon Machine Images are a packaging format that we use to make software available to run on the cloud. When you create a virtual machine, you specify an army, and that defines what operating system and what software will be loaded on the new machine that you create. We actually announced an army specifically for deep learning, so it includes several of the popular frameworks, including TensorFlow and our own Destiny deep learning framework as well. So I'd encourage you to take a look at that. If you've got feedback and you want to see more, you should let us know via the EC2 service forum that we have. Our service teams, our engineering teams hang out there and they look for customer feedback in those forums. So take a look at what we've shipped and let us know what you think of it. It'd be really helpful to do that. Yep. One more question, maybe? Okay, oh, here we are. Good, thank you. There's one more question down here, guys. This young lady asked a question.
I'm about to start a business about data, and there are lots of technologies out there. So how do you convince me to go for Amazon Web Services?
So we do a lot of work with startups. We've got a program called AWS Activate, actually, which startups can use to get access to free services from Amazon Web Services. So that might be one way can convince you by giving you some free stuff to build your product on. If you go to awsamazon.com/activate, you can find out information about that. But basically, the reason that startups use AWS, and most tech startups that are building in the cloud do use us, is because it allows them to defocus from activities that do not help them deliver the most compelling service proposition to their customers, and also that might distract from their ability to create a viable business model, to create a business model that works. And I would say, regardless of whether you use AWS or another provider, you should definitely build your products in the cloud. Don't get into investing capital in data center infrastructure. It doesn't help you. It's very inflexible. And if you find out that you need to pivot and change direction with your business, you could find that you've got a lot of assets that you can't use anymore. So it's much better to build on service platforms. It might be the AWS platform, it might be others, but I really would say that if you're starting a business today, the best way to do that is in the cloud. Spend all of your efforts listening to your customers and trying to build the best unique IP that only you have. But don't repeat things that others have already done, because those areas have already been tackled. In some cases, they're already commoditized. They're not going to find a viable model if you do that. So focus your effort on trying to build the most compelling product for your customers. Okay, we're out of time. Thanks for coming for this session. Find me here if you have more questions. Thank you.